Hello everyone, today's video is testing right here. So this is the simplest high voltage supply you could ever build, and it can be pushed pretty damn far. I do not have a voltage limit yet, which is why I put this here from 3 volts up to, we will find out later. Now this is the capacitor right here. This helps for the oscillation and makes an LC tank circuit. This capacitor can help on the secondary. You can add more capacitors later on. But for now we don't really care about this capacitor or the capacitor on the output, because we care about this circuit schematic. We have this is the feedback coil. This right here is the diodes and resistors. I couldn't get a 30 ohm resistor, so I saw the 310 ohm resistors in series. And this diode, this is a UFD 4007. It's the best all-around diode used in everything from ZVS2. And I have this diode for feedback. This is helping the circuit oscillate, as I said earlier. And this is the transformer itself. Now, if you're building this circuit and it doesn't work, just switch the feedback winding. This is feedback and this is the primary. Primary is the thicker one. So primary is the thick one right here. And here they are connected together, the feedback and the primary. Turning on my power supply and not powering it on yet. I got so accustomed to my ZVS that everything that I power now, I hard switch it from 0 volts. On the ZVS video coming soon, but right now I really need to get some resin or something to pot my transformer in. I'll use the other circuit because it's better isolated. So this is the ground right here. Not a good thing to make your wire the same color, but good if you know what you're doing. And this is the positive. Here I'll show on this one because this is clearer. The feedback and the primary connect together. And this is the ferrite core transformer. This is actually a very good transformer. High step up ratio. But there's one problem, it's small. See, that's like a few kilovolts. Yeah, high voltage likes to arc. That's the problem, that's why I need to pot it in resin. I'll pot this in resin later on and probably use it for my voltage multiplier, but I'll use something else for DVM probably. For better contrast, I put this on my table because manganese dioxide is also on my table. Manganese dioxide just gets on everything. All the dirt you see on my table is just manganese dioxide and hot glue maybe. At around 1 volt actually. So the circuit starts oscillating at 1 volt, but the output is negligible. And now I want to test something. It's outputting something, I can see it. It doesn't shock me, it just won't shock me, because it's very high frequency, which is why I said this is the best high voltage power supply you could build. It's not exactly high voltage as in 100 kilovolts or more, but it is pretty high. Why is everything wrapped in electric tape? High voltage isolation. This is for stuff like this. If it's higher power, I don't want to burn myself. And this for electrical isolation. Now let's see how far can we push it. So this is 3 volts. This is the good voltage for it. Pretty good. That's pretty good. I'll zoom in. Now I've zoomed in 10 times, tenfold. And it arcs to my screwdriver like a Tesla coil actually. So yeah, the arcs are pretty nice. I'll let my MOSFET cool down. I can actually put it on this humongous heatsink. I try to tap it. I got some thermal paste on here. Now I see a lot of people online that don't know how to put thermal paste on. You don't spray it with your fingers. You don't use the spreading tool. What you do is you just put it on there, compress it, just like in a PC. It should stay down with just compression. So now again, let's see. My transformer isn't shut. So now the other transformer arc over at this voltage. Ramping up the voltage. Look how far it's arcing. Barely cold. Let's push this. At 6 volts it does this and draws 3 amps. Obviously the circuit draws a ton of amperage, because if you're gonna amp the voltage that much, you can't just get energy out of thin air. So no, Tesla didn't tap into free energy. Okay, I'm suspecting this is internally arcing. Let's see it with no light. Now that I've ignored all high voltage safety, but I'm still using a chicken stick because I am never holding high voltage wire with my bare hands. Let's power. Make sure this is not an arc flash. DC hurts way more than AC because of the skin effect and whatnot. And that's high frequency, so the skin effect is pretty strong and it doesn't hurt me at all. It barely burns me because it's low power. But this is gonna hurt. Hey! Look at the power going on. We've officially multiplied the voltage. It's like this is what this circuit was built to do. Oh my god! We've actually multiplied the voltage with the Yeah, I'm just joking. That was 1 volt, I think. This is not high voltage setup, as you can see. I'm not expecting millions of gazillions of volts. That's why I chose the tiniest chicken stick I had on stash. That's why I'm not even. Good, that's good. Oh, actually, I forgot one thing. Yeah, I think the resistors cook themselves. They're not high voltage resistors at all, so they just cook themselves, so that just gives me a lower voltage. I wonder if you could post this. I'm just joking, I won't do that. What, you expected me to go to that? That's a horrible idea, not enough amperage. Let's just play with it even more, because you know, playing is fun. Actually, thinking about it, this is the safest way to play with the voltage multiplier. So now I'll do this. I'll check the voltage on different stages. Good. Good, good, better. Actually high voltage here. Charge this. This is actually high voltage. I cannot believe it. Now, I'll test the highest voltage this thing can handle. I don't have my transformer in frame. I'll be checking on it and I don't want to get zapped by this thing. No, internal arc. At about 6 volts, it killed itself. Yep. I would not want to be shocked by that. Maybe after there are layers of resistors. Yeah, maybe you could touch that. Now let's test static electricity. Okay, so now let's test two things. This is small length, so this can make arcs. You see, static electricity attracts it closer. It works. You can hear the electrons. So let's test this again. We got the closer one. Now with the yeah, static electricity. Hey, come here. Now this one. I explained yesterday, this is another day, how the feedback flyback driver works. But I didn't explain this. This is a voltage multiplier, and on every cycle of the AC, it charges up one different capacitor and then discharges them through the diodes, giving me a high voltage right here. I'll disconnect myself from ground because I don't want to hurt myself. Yeah, I say that's pretty good. And these are still charged. That was still charged. That acts as a capacitor. This was about it for today. See you next time.